Hey class, I wanted to give you an overview of the lab. So let's start from the start. You're logged in, same as usual, and there's just a few things you need to do to get set up. You need to get the Lab 5 code. So I've already done that and put it in a little directory here. So I'm going to go in and open the project. It's called I2C. Just double click that, Kyle will start. So that's running. Code is super short this time. I'll go through it. You need to see the camera. So let's open up the camera. And I'll go through this in a second. And you need this program called TerraTerm. And I'm just going to quickly do this, but I'll come back and I'll show you exactly what you need to do later. And you need the scope. And we connect to the remote front panel. There we go. So this has already been set up, obviously. It's beautiful. So let me go through a little slower each component. So let's go to the camera first. I'll show you what's on the camera. So this is your setup this time. We have an LCD display panel, and it's showing temperature. And the temperature should correspond to the numbers scrolling up the screen over here, and they do. You have Zigbee modules. If you're not familiar with that, it's similar to Bluetooth. It's a lower speed, lower power protocol. We've got a transmitter and a receiver here. It seems kind of ridiculous that they're side by side, but the idea was to get you using Zigbee. Of course, they could be placed on opposite sides of the room, and then you could transmit wirelessly your temperature data. We have a temperature sensor IC, and you have the data sheet for that in your lab handouts, and it's underneath this white square, so you can't see it. The white square is a Peltier cooler. So if you're not familiar what a Peltier cooler is or what it does, I'm going to link you some information on the CUlearn site so you can read about that. You have an Arduino underneath here, and that's controlling the Peltier cooler. And you have, well actually I don't think it is anymore. The Peltier cooler is connected directly to a function generator. So I misspoke. That was the original idea, was to get it connected to the Arduino. So the Arduino is not really doing much in this lab. And then we have a USB to UART converter. So on this side we have a USB plug, you can sort of see it there. And then we have the converter chip, also the data sheet for that is in your lab. And then we have the UART signal lines. In particular, we have a ground, a TX, and an RX. And that's brought up to the Zigbee modules. So one Zigbee module is connected directly to the microcontroller, and the other Zigbee module is connected directly to the PC through this converter. What else? Oh, scope probes. So these scope probes are attached to SDA and SCL on the I2C bus. So that's everything on the screen. So far, so good. Let's take a quick look at the code, I suppose. So you guys should go through this in some detail. I've commented it pretty heavily, so it shouldn't be an issue for you to understand what's going on. We've got a few pins dedicated to the I2C bus. We've got a few pins dedicated to the UART, so those are defined here. The LCD, it's not really part of the lab. You're not really doing that much with it, but I left the code in here so you could see how you could print to it and control it. So there's a special group of functions just for dealing with the LCD, and it takes a fairly large number of pins actually to control it. So it's got its own 4-bit bus, it's got a control line, it's got an enable line. So those are all handled by this function. And then we set up the I2C interface. So this is all embed functions, which makes it so easy. Otherwise, you'd be writing pages and pages of code. We set up a serial interface to Zigbee, and we set the address for our slave on our bus. So I've explained to you how that works. Actually, I was scratching my head about it a little bit yesterday because first of all, the code I inherited did not have 9E and had the wrong number. So I figured that out. So embed is a little weird. It requires you to left shift the byte by 1 bit, and then it uses the least significant byte as the read-write byte. And then we get into our main function. So we set up a storage location for the 2 bytes that we'll be reading from the temperature sensor. Look at the data sheet and you'll see that it does send 2 bytes, but there's only 10 bits of the 2 bytes that are actually used. We zero those out just to make sure. We do a write here. So I'm going to ask you what was written and why in the lab. Then we do a read of 2 bytes. Again, what was read and why. You'll have to explain this line of code. Then we print to the wireless Zigbee. So again, it's just a serial interface with C format string to print the temperature. We also print directly to the LCD, a similar C format string. If we didn't get any reading, we're going to print an error to Zigbee, and that'll show up over here. I'll get into this Terra term again. And then we wait for 0.1 seconds or 100 milliseconds, and then we jump back up and we go through it again. So we're always collecting temperature data. Okay, so that is the C code overview. Now, Terra term. Let me kill Terra term. And watch how I kill it. I want you guys to always do this as well. Go to File, Disconnect, and then kill it. Okay. So I'm going to show you a few things with Terra term. Start it. Now, it can either do TCP/IP protocol and connect through, for example, SSH to another server somewhere, or you can do serial. So we want the serial, so you click on that. Then you have to choose which serial port. We don't actually have a serial port on this computer that you're using in the lab. So that's why we use that converter chip connected to USB. So you have to go down and choose COM8. It could be a different number, by the way, on your computer. So look for USB serial port. Select it and hit OK. And then you're connected. So what's happening here is the microcontroller is streaming data to that port through the Zigbee interface. I'll provide you a sketch of how the system is set up. And this thing is simply a terminal program which collects that data and displays it for you. Let me enlarge this a bit here. Why is Windows so finicky about this? I just want to grab the corner. Do it that way. That's a bit taller than I wanted. Let me try that again. Okay, so now we can see more stuff streaming. You can see some garbage characters sometimes. You guys might want to investigate why that happens, and then they kind of disappear. There's not much else to it. It's just showing the temperature. What you need to do as part of the lab, though, is capture that data. I don't think you want to write it out by hand. That's like second-year stuff. So instead, you can go here to log. Okay, and then you can give your log file a name. Let's call it temperatures, and maybe call it .text, so it's easier to deal with later, and then hit save. Okay, so now if I go back to my directory, where is it? Right here. I'll go back up here to Lab 5, you see a text file has been created. It's already up to 6 kilobytes. I can open that and take a look in it. And it's got my data. You know, those garbage characters are there. I'm going to leave that for you guys to figure out. That's fine, though, as long as the temperature data is good. So I want you to plot that at some point. You'll have to figure out how to get rid of everything before the equal sign. I'm sure you guys can do that. Use Excel, for example. You get a nice plot of the temperature over time. Okay, so that's Terra term. And for the scope, I'm going to make a separate video because the scope is pretty detailed. So that's the overview of the lab. Pretty straightforward. You'll get a bunch of questions on things to do with the code and things to investigate with the scope and so on. And by the end of it, you're going to understand I2C a lot better than when you started this lab. For most of you. Some of you are already experts, I'm sure. Okay.